Okay, today we are going to learn about 1210, solving systems of linear and quadratic equations. I'll try to make this as painless as possible. If you at any time need to stop and take notes, press pause. If you need to rewind, obviously do that so you can see, you can get a little more clarification by hearing me teach it twice. Make sure you are taking notes though. This is not just a video that you're going to watch and zone out on. All right, here we go. So number one, what are the solutions of the system? So it looks like the first equation is a quadratic, which means that it is going to be a parabola when we graph it. It's going to look something like this. The second one is a linear equation, so it's going to look like a line. We're trying to solve for the system, which means we're trying to solve for the point where they cross. So I'm going to first graph my line. That's the easiest part. 5 is my y-intercept, so 1, 2, 3, 4, 5. My slope is -2, which means I go down 2 over 1, down 2 over 1. I don't know where these two graphs are going to cross, so I'm going to just make sure that I graph as many points as possible. Don't make fun of my non-straight line. I don't have a ruler. Okay. Next thing is the parabola. It looks like it has a vertical shift of 1. So it's going to start right here, where as opposed to the parent graph started at the origin, it's going to start 1 up from that. And then 2 is my a value, which means my jumps would be 1, 3, 5. Since it's 2, instead of going over 1 up 1, I'm going over 1 up 2. Over 1 up 2. And then instead of my next jump being 3, that jump is going to be 3 times 2, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. As you can see, it looks like they cross here at 1, 3, and they cross over here at -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the solution to this system would be 1, 3, and -2, 9. So that was how you solve systems by graphing. Now we're going to learn how to solve systems by elimination. Since opening day, attendance at pool A has increased steadily, while attendance at pool B first rose and then fell. Equations modeling the daily attendance Y at each pool are shown below, where X is the number of days since opening day. On what days was the attendance the same at both pools? What was the attendance? So we just want to solve. We're asking what day attendance was the same. Since this is the elimination slide, we are going to add or subtract. Y's are on top of y's, the equal signs are on top of equal signs. I do not see x squareds on top of each other, so we're going to need to do a little bit of rotation, or a little bit of shifting around here. So the first equation, y equals, well, I don't have an x squared, so I might just put 0x squared, and then plus 28x plus 4. Underneath, y equals -x squared plus 39x plus 64. If I were to add down, I'm not going to eliminate any variables. So what you want to do is try to eliminate the y's. So what I could do is two things. I could subtract the bottom equation from the top equation, or I could multiply the entire bottom equation by a -1. I'm going to actually just subtract. Y minus y is 0. 0x squared minus a -x squared ends up being a positive 1x squared. 28x minus 39x would be minus 11x. 4 minus 64 would be -60. From there, if I want to solve for x, it's a quadratic, so I'm going to need to factor. Hopefully it's factorable. It makes our lives easier if it is. So I need to figure out what factors of 60 would give me 11 if I'm adding, or -11. So we've got 1 and 60, 2 and 30, 3 and 20, 4 and 15. Looks like that's it. 4, 15. I need it to be a -11 when I'm adding, so the 15 is negative. 4 would be positive. If I solve, x is going to be -4. And x is going to be 15. If we interpret this with the word problem, x is the number of days since opening day. So on what day is the attendance the same? Well, you can't have -4 days, so it looks like day 15 is when attendance is the same. You throw out the -4. It also asks what was the attendance on that day. So you can plug x back into either of the two original equations to find the attendance. I'm obviously going to choose the first equation. So I've got y equals 28 times 15 plus 4. From there, you just figure out what y is. So 28 times 15 is 420. Plus 4. So y equals 424. That means the attendance was 424. Okay, that's how you use elimination method. On this next slide, what I'd like you to do is pause it, complete this problem in your notes. So read the question, solve by elimination method. Once you are done, unpause it, and then I will show you the solution on the screen. So pause it right now. Okay, this means you've already paused it, you've already finished the problem. Here is the solution to this problem. So pause it again, and then you can look at your work and look at the solution to see if you did it correctly. Okay, moving on. Now we're going to learn how to solve using substitution. So on this first equation, notice that it is a parabola. We've got an x squared. Second equation is a line. So if we're going to solve by substitution, I need to know what y is or what x is. So I noticed that y is 4 minus x, so I'm going to plug it into the equation up top. So that's going to be 4 minus x equals x squared minus 6x plus 10. All I need to do now is get everything to one side because it's going to eventually be a quadratic in standard form. So I'm going to subtract 4 from both sides. I'm going to add x to both sides. And I get 0 equals x squared minus 5x plus 6. Factor that. What two numbers, when multiplied, give me 6, added give me -5. So a -2 and a -3. So x equals 2 and x equals 3. Now, those are both x coordinates. That does not mean the two graphs cross at 2, 3. What it means is, if I were to graph it, x equals 2 and x equals 3, that means the parabola and the line are going to be crossing somewhere along these lines. So what I have to do is find the corresponding y value to these. So I'm going to plug x back into one of my original equations. So y equals 4 minus x. So in this case, 2. So y equals 2. That means one of my points of my solution is 2, 2, because x was 2, y is 2. Now when x is 3, y would equal 4 minus 3. So that means y is 1. So the other solution to my system is 3, 1. So it looks like they'd cross at 2, 2, and they'd cross at 3, 1 if I graphed both of those. So I'm just sketching this completely, but it would look like maybe something like this. And that's where they would cross. Okay, same thing. I'd like you to pause right here, complete this problem using substitution, and then when you are done, unpause it, and you will see the solution up on the screen. Okay, here's the solution. You can go ahead and pause that, look at what you've written on your paper, see if it's correct, try to catch your mistakes. Okay, we will not discuss this, but solving with a graphing calculator, all you would need to do is plug both of these equations into your y equals. Then you would use press the second button, trace, and then you are going to use the intersection feature. And it will show you where the two equations cross. Okay, now you will be given a worksheet to practice. You can go ahead and complete that and then turn it in when the bell rings.